Hi class, we are on chapter 10. The chapter is solids, liquids, and gases, but we're going to start with chapter 10.1, interactions between particles. In chapter 1, we discussed the three common states of matter, also called phases of matter: solid, liquid, and gas. We saw that the macroscopic, which is the human scale, what we can see with the eye, properties are function of their structure on the atomic or molecular level. In a solid, particles pack closely together. Each particle is held in a fixed position by the particles around it. In a liquid, the particles are close together, but they are not held in a fixed position of each other. in a fixed position. Particles move freely past each other. In a gas, the particles move independently of each other. They are spaced far apart and have little or no interaction with other gas particles as they move. A transition from one state of matter to another is called a phase change. For example, let's look at the phase changes that take place with water. In ice, the water molecules pack tightly together. If we add heat, which is kinetic energy, movement, motion, to the ice, the molecules in the solid will vibrate more rapidly. If we continue to add heat, the molecules gain enough energy to overcome the forces that hold them in place. They break out of the solid framework and begin to move freely past each other. The ice melts, a phase change from solid to a liquid. If we then heat the liquid water, the molecules move faster and faster until they break out of the liquid phase and into the gas phase. Particles in the gas phase move about freely, interacting with very little with each other. For a substance to change from a solid to liquid or a liquid to gas, there must be enough kinetic energy to overcome the forces of attraction. The stronger the forces between the particles, the greater the energy required to phase change. So basically, the greater the energy to get that to change from one substance, it's the same substance, but a different phase. Substances with very strong forces of attraction between their particles have high melting and boiling points. We can use the phase transition temperatures to understand and compare the forces that hold substances together. Okay, so what state of matter adopts the shape and volume of its container? It's not a solid, because a solid has a fixed shape which you cannot change unless you break it. So it's going to be gas. A gas will take up, think of somebody wearing either cologne or perfume or some kind of fragrance, and they walk into a room and you're sitting on the other side. Eventually, you will smell, if it's strong enough, you will smell that. That's a gas. Those molecules will push until they feel resistance. So if you start from one side of the room, that fragrance will keep going until it hits a wall or something that's going to stop it. That's why you'll smell it over from the other side. Which of the following statements is true? Solids sublime into liquids. A molecule in a liquid has more kinetic energy than the same molecule in the gas phase because liquids are more dense than gases. Boiling water is an endothermic process, and particles in the gaseous state cannot be changed directly into solids. Boiling water is an endothermic process. So remember, sublime means that it goes right from a solid to a gas. Make sure I'm saying that right. Okay, sublimation is a physical change of when a substance changes from a solid state directly to a gaseous state without going into the liquid state. Boiling water is an endothermic process because if you think about it, you put a pound of water on a stove. When you heat it, that heat, the energy, you see the heat, but you don't see the energy. The energy is actually, it's increasing the kinetic energy in the boiling water. So it's allowing the energy, the water is taking in that energy as heat. So this is an endothermic